Welcome to this video on leaderboards. In this video, I will cover a custom Datastore module as well as a leaderboard that saves data. World link will be in the description.
Roll the intro.
Okay, to start off, I'm going to show you how to create the custom Datastore service module that I'll be using to store data for this video. You can skip ahead via the timestamps in the description or using the video player if you'd like to get straight to making the leaderboards. Alright, first we need a module script in server script service. I'm going to rename it to custom Datastore service, as that is what the module script is going to be. Okay, the first thing we're going to do is remove all the default code generated in the module script. Next, we need to assign the Datastore service to a variable. We are going to be accessing this service multiple times throughout this part of the video, so it is a good idea to store it in a variable. For this video, we are focusing on the Datastore service provided by Roblox and making some improvements using this module. You can store your data in other places too, such as external servers, but that is a topic for a different video. Next, we need to define some variables. The first thing we'll need is our Datastore. My Datastore key is going to be CDS, representing custom Datastore. Next, we should define our custom Datastore table, which will hold our methods for this module. The way this module works is simple. It will save data in a table and only save it to the default Datastore service when we ask it to. This helps with rate limitations and gives us faster access to the data. So let's create another table called loaded cache, which will store each player's loaded data as well as any data we set to the table. Next, we will need a key to use when we are saving or loading data from our Datastore. This can be anything you want. If you change this when data has already been saved, it will create a new Datastore and you will no longer have access to the previous data. Well, unless you change the loading key back to what it was originally. Alright, now we move on to functions. We need to be able to load player data, so let's create a function for that called load player data, giving a player parameter. We'll use a pcall as an error catching method in case something goes wrong while fetching the player's data. Inside the pcall, we'll set the loaded cache for the player to the data we are fetching from the default Datastore. We fetch the data using the getAsync method for the Datastore, and we'll set the data to the player's specific loaded cache using their user ID. We also want to customize the loading key by concatenating the player's user ID with the default loading key. If an error occurs, we want to output the error information as a warning. We also want to set the player's data to an empty table if their data cannot be loaded. This will likely be because the player is a new player. Next, what if we want to access some of the data we previously saved? To do that, we will create a method called get. Notice how I used a colon after our CDS table. That means we are defining a method to the table. For this method, we will need the player, a key, and a default value as parameters. If the player's data is not loaded, we want to load their data before returning any value. So if we can't find any loaded data for the player, we want to call the function we defined earlier called load player data and pass the player as a parameter. Once we confirm the player's data has been loaded, we want to return the value associated with the key. If there's not any data associated with the key for that player, we want to return either the default value, if it was provided, or a nil value. Alright, what if we want to store some data or set data to the loaded cache? To do that, we will create another method called cache. If the player's data is not loaded, we want to load the data before setting any value. Once we confirm the player's data has been loaded, we want to set the value associated with the key for the player to the value of the value parameter. We can also create another method called set, which will do the same thing as the cache method. This provides an option for the user, or ourselves, for what we want to use when changing or saving data for a player. The last method we will define is called save. It requires one parameter and only one parameter, the player we are saving data for. If the player's data is not loaded, we want to return. This is because we don't want to save data if there is no data to save. If there is data to save, on the other hand, we want to compare it to the data that is already saved to the Datastore. To do this, we will load the saved data onto a temporary variable called saved data. If an error occurs loading the data, we want to output the error in the form of a warning. If there is no saved data, we want to save any data we have for the player. We do this in a peek call to catch any fatal errors that would otherwise break the script. If there's an error saving the data, we again want to output the error in the form of a warning. If there is saved data, on the other hand, we want to directly compare each value in the saved data with the data we want to save. If anything is different, then we want to save the data to the Datastore. Lastly, we want to return the CDS table that holds our methods, and only the CDS table. Alright, something I noticed after I recorded the custom Datastore module section resulted in data often not being saved. This occurred when you removed something from the cache that was initially in the saved data. Since the item was removed, it will no longer compare the saved data with that key to the loaded cache with that key for the player. Unauthorized saved may have resulted without these bug fixes. First, we want to check if the size of the loaded cache for the player is different from the size of the saved data. To do this, we will create a method called compareArraySize with two parameters, which are both tables. In here, we will iterate through each table passed in the parameters and increment a variable for each element in the tables. We will return both counts. Then, we should use this function to count the saved data and loaded cache for the player. If they are not the same size, we should save. Now that I mentioned saving, the way we save our code is kind of messy. We should create a single function and call the function each time we want to save. So let's do that. We'll create a function called savedData and simply copy our saving code into the function and call this function each time we want to save. To get started with the leaderboard code, we will need a script in server script service. I'm going to rename the script to leaderboard_server since the script handles our leaderboard on the server. In some cases, you could have client-side code indirectly interacting with the leaderboard through events. Just like with the custom Datastore service module, we are going to define the services we use as variables. In this case, we are going to be using the player's service. Next, we need to load our custom Datastore service module using the require keyword. Now if a module is only used by one script, I like to parent the module to that script. When a player joins our game, we want to initialize their leaderboard. We do this by using the player added event from the player's service. We will start by creating a folder. We must now give it a name. Now the name must be, and this is important, leader stats in all lowercase. We should then parent the leaderboard folder to the player. Next, why don't we create a coins section for the leaderboard? This will display an int value. Now, int values are similar to number values, except they must be whole numbers. Now, we should give the player their saved coins, if they have any, using the custom Datastore service module. So that looks something like CDS:get player, coins, 0. Now 0 would be the default value in this case. Now we want the player to know what the value in the leaderboard means, so we should give this coins instance a name. Finally, we should parent the coins instance to the leaderboard folder. When a player leaves the game, we want to save their coins for the next time they join our game. So we will do this by using the player removing event from the player service. What happens if the server shuts down when there are still players in the server? To handle this, we will use the game bind close method. We'll bind our function to an event fired when the server closes. Let's utilize this to save our player data. This code here was redone off camera to add a self-made limitation on how often a player's data can be saved. This also helps if a player leaves and then the server closes immediately after. The last thing we need to do is make the cached value for coins update when the player gets more coins or if they lose coins. To do this, we'll use the changed event. This event fires whenever the coins object is, well, changed. Alright, here I'm just adding a script inside the part and checking when a player touches the part. If the player touches the part, then we're going to add a coin to the player's leaderboard. Something very important if you're testing in Studio is to make sure you have Studio access to API services turned on. Alright, let's go ahead and launch the game. So you can see I started with 71 coins, but let's get it up a bit more so you can see it's working. Get it up to about 140 coins. So yeah, 138 coins. Alright, let's close the game. And we'll relaunch it. Now as you can see, 138 coins saved since we left the game. That's all for this video. Don't forget to hit the notification bell so you don't miss any new content, and subscribe if you are new. Next week, I will release the next episode in the beginner scripting series. World link is in the description. Supreme scripter applications are still open in our Discord server. Apply before October 7th so you don't miss your shot.